Dear students, I am Professor V.R. Shilwant, Electrical and Electronics Engineering Department, SDMCT Dharwad, Karnataka. In this video lecture, I am going to deal with turn, coil, winding and winding factors. First, we will define what is turn. It is series connection of two conductors Now let us see how a turn may be formed. For that we will take two conductors, namely conductor 1 and conductor 2. This is conductor 1, this is conductor 2. Now we will join them end to end to make series connection. These are the free ends of a turn. Next, we will define what is coil. It is series connection of two or more than two turns. So to form a coil, go on connecting many turns in series. A coil may also be shown in very rude way. As here now. Every coil has two coil sides which are shown as perpendicular lines in the coil. Next, we will see what is winding. Series connection of two or more than two coils is called winding. A winding may be obtained just by connecting more than two number of coils in series as here. I will name these coils as coil 1, coil 2 and coil 3. EMF induced in a turn is phasor sum of EMF induced in each of its conductor. EMF induced in a coil is phasor sum of EMF induced in each of its turn. EMF induced in a winding is phasor sum of EMF induced in each of its coil. If If one coil side of a coil lies under N pole, then its other side lies under subsequent S pole. If the two sides of a coil assume same positions under N and S pole, then coil is said to be full pitched coil. For a full pitched coil, the EMF induced in each coil side are in phase. Therefore, the algebraic and phasor sum of EMF induced in coil sides are equal. if the two coil sides of a coil assume different positions under N and S pole, then coil is said to be short pitched coil. For a short pitched coil, the EMFs induced in each coil side are out of phase. Therefore, the algebraic and phasor sum of EMFs induced in coil sides are not equal. Let us try to understand the full pitched coil and short pitched coil along with the EMFs induced in them. So on one side I will draw the full pitched coil, and on the other side I will draw EMF induced in it. So these are the two poles, namely N and S. Let us draw the pole axis here. Pole axis is nothing but a line passing through center of pole. Just under these pole axis of two poles, I have shown here the two coil sides. Here is coil side 1 and it is coil side 2. Let EC1 and EC2 be the EMFs induced in coil side 1 and coil side 2 respectively. These EMFs may be now shown as two phasors in phase. The total voltage induced in the coil is the algebraic sum of the EMFs induced in each coil side and is equal to the phasor sum. Now we will see a short pitched coil and the EMF induced in short pitched coil. Again, we will consider two poles N and S. The pole axis and a coil whose two sides are not placed exactly at same position under the two poles. So here we can see coil side 1 and coil side 2 not placed at same position under two poles N and S. Therefore, the EMFs induced in these two coil sides are out of phase and the total EMF induced in the coil is phasor sum of EMFs induced in each coil side. The EMF induced in short pitched coil is therefore lesser than the EMF induced in full pitched coil. Now we will define what is coil factor or a pitch factor. Coil factor or pitch factor are denoted by Kc or Kp. Coil factor or pitch factor is defined as the ratio of phasor sum of EMF induced in each coil side of a coil to the algebraic sum of EMF induced in each coil side of a coil. For full pitched coil, the coil factor value is equal to 1, and for short pitched coil, the coil factor value is less than 1. Next definition is concentrated winding. A winding with its all coils placed in two slots is called concentrated winding. Next definition is distributed winding. A winding with its all coils placed in many slots is called distributed winding. Another important definition is distribution factor or winding factor. It is defined as the ratio of phasor sum of EMF induced in each coil of a winding to the algebraic sum of EMF induced in each coil of a winding. For concentrated winding, Kd or Kw is 1. For distributed winding, Kd or Kw is less than 1. In next video, we will derive an expression for EMF induced in a three-phase alternator.